Do you see? Yes, I think you see the point there. So what are critical raw materials? Okay, you know, a raw material is something that it's a primary element to another thing, but these raw materials, they are critical because they have like three properties. Okay, they have the first one, there is an absence of a substitute for a specific application. They have very particular properties that make them very useful for some specific applications. Then they have an economic importance because they are used for all this kind of residential, for green technology. And finally, there is a risk of supply because, first of all, here in Europe, we don't have too many mines or too many places where we can extract these critical raw materials. So there is a high dependence on imports, okay? And also, there are not too many countries where we can find these critical raw materials. So we have also some difficulties to try to import them here in Europe. Okay, so if you see, this is like a map of the critical, the main producers of the critical raw materials. And as you can see, for example, from China, okay, we import most of the critical raw materials. So you can see, for example, for magnesium or those rare earth elements, we need more than 90% of the elements of the amount that we use here in Europe. We have to import from China. Also, there are others elements from the platinum group metals. Okay, like iridium or ruthenium, that more than 90% of the needs that we need here in Europe, we import from South Africa. And in particular, here in Europe, we have a okay, an extrusion that it's produced here, is extract produced here in Spain. That, as you can see, they are like the two elements that more or less we achieve to import or to use everything from the amount of critical raw materials that we extract from our territory. But as you can see, for all the other critical raw materials, we depend from countries from abroad. So what makes or how Europe says, okay, this is a critical raw material or it's not a critical raw material. So here we have a graph. As you can see, there are with points, there are blue and red. These are all the critical raw materials that they are analyzed every 3 years. They analyze and they analyze in with two variables. First variable is the economic importance. Okay, they divide and they classify them. Then they also classify with the risk supply, how if it's very risky or if it's easy to import them from other countries. So with these two variables, we then get like a diagram and they decide to put economic importance if it's more than 2.8 and risk supply if it's more than 1. Then, as you can see in this box, all these elements that go into this box then are considered critical raw materials. This is not something that is fixed and it's okay. This is for today and it will be in 5 years the same or in 10 years. No, this is something that is changing depending of the economic importance and the risk supply. Okay, depending of the countries and maybe the amount of play resources if they discover war or if there are wars in some places or something like that. So every 3 years they make like a new report, and sometimes there are some elements that enter in the new list, and also it happens that some of the elements they go out of the list. Here are the 30 critical raw materials that they come in the report of 2020. And also, as you can see, there is like a little, well, it's a little bit tricky because there are also three critical raw materials that they are not only just one element, they are like a group, okay? We have two groups, the group of heavy rare earth elements and also the light rare earth elements that, as you can see, there are more than one. And also we have the platinum group metals that we will see afterwards in the periodic table. And as you can see, okay, every 3 years we have a new list. As you can see, the critical raw materials have increased during the last years from 2011 that there were 14 till now that in 2020 we have 30. But also, as you can see, like in 2014, we got chromium and magnesit, or in the last report, we got helium that nowadays they are not included in the final list. So if we take a look at the periodic table, you can see more or less which critical raw elements are included in the list. As you can see, these were like the platinum group metal elements, and also what I was telling you before, also that group of light and heavy rare earth elements. Okay, so where do these critical raw materials come from? So most of them is the natural rubber, okay, but most of them they come from minerals. They come from minerals from the earth, and we have to extract them. So some of them, like for example beryllium, that it comes from bertrandite mineral. We have dysprosium, okay, that it comes from like a mix of sands, okay. It's not like it don't have a main mineral. It's like a byproduct of another minerals. But also we have others like phosphorus that we don't have like just one typical mineral where we can get this element. We can have more than one typical minerals like apatite or pyromorphite. And what I was telling you about the applications, what happens? For example, beryllium, it has like a dimensional stability over a wide temperature. So this makes uh, that it's easy to use it like in the satellites, okay. But also, for example, it also has a great stiffness and strength combined with a low density. So what does it means that that's why it's used like in the wheels of the airplanes. Also, we have, for example, this dysprosium. It has like very specific property that increases, okay, the what is called the cooling temperature, okay. That allows the use of permanent magnets at up to 200 degrees, and that's why we can use, for example, in one turbines, okay, for all the green energy. Also, we have like phosphorus that, as you know, is a biological element. Okay, it's very important for the fertilizers, but it's also used in, like, for example, in detergents to soften the water, and also in fire extinguishers. Okay, so this is more or less the introduction to critical raw materials. I more or less I tell you, okay, there is some risk of the supply, but also we have another problem, and the problem is the social and the environmental impact that they can have in the environment and also in the society. So what happens? Okay, usually these minerals we have to extract from the earth, from the subsurface. We have doing these operations, we have different environmental impacts, such as, for example, for the atmosphere. Okay, when we make this kind of explosions, or the vehicles that we were using in these operations, they emit some dust and also greenhouse gases to the atmosphere. We have also some effects into the rivers and the lakes. First of all, it's about the acid main drainage, that it's because of the sulfur. Okay, this more of the minerals, they are sulfide minerals. So this makes the water to have a very low pH. That because of this low pH, that is around 2 or 3, it can affect not only the rivers, but also it can mobilize the heavy metals, so they can travel and they don't stay in that place, but also they can travel to the to other environmental compartments. We have also some effects on the geosphere. Okay, that usually also the open pit mines, if you see, they are like a very big holes. Okay. And also in the biosphere with they affect the biodiversity, deforestation, and also most of the times we lost some soil that it could be used for agriculture. But we don't only have mining environmental impacts. We also have some mining social impacts, such as we have some diseases, no, that they are related with the mining work. We have this kind of asbestosis, silicosis that they affect to the lungs. Also, there is usually or sometimes there is a risk because if there are some kind of explosions or some rocks, they can if they close or if they fall. Some people, if they are working there, they can die. But also we have in the usually in the undeveloped countries, we have these problems of sexual exploitation and also and many times these critical raw materials they are used to have money for all these civil wars that usually if you see the news they are it's like the diamond or it's like the gold that we have sometimes this kind of wars and usually what they use they are these critical raw materials to have money for for buying this kind of firearms.
Una movida que me han mandado los de
Pero este no.
So, uh, well,
Mus.
here I think that all of you have like a smartphone. If you don't have it in your pocket, maybe it's in your table or something like that. But what happens with a smartphone? It requires more or less like around 50 different raw materials, and a lot of them they are critical raw materials. And as you can see, okay, here in if you see the colors, uh, well, what happens that most, okay, there are some elements that they have like high rates of recycling, but most of them and also the ones that they are critical raw materials, they have like a rate of recycling that is less than 1%. Okay, so what we are doing, we are extracting them, we are using a lot of energy, we are using a lot of water and a lot of resources to extract them from the mine, and then we use, and finally when we use, we throw it again and we don't recycle and then we don't use it again. So just for example, okay, if there a mobile, okay, it has like 0.04 grams of gold, and if you see to extract or just 1 gram of gold, okay, you need around 1 kilogram of explosive, 4 tons of rock, 380 liters of water, then you need like more or less 1 kilogram of sodium cyanide that is a very toxic element that then when they extract the gold this usually ends in the environment affecting the ecosystems. You need also fuel, 2 liters of fuel, and then around 3.6 of electricity. That is more or less what a family uses every day. Okay, that's just for 1 gram of gold. And if we see, okay, the EWaste generation, okay, that all the waste that we generate every year in the world, as you can see, this is from 2019, and we are producing around 53.6 megatons, okay, of all these kind of electronic devices. Uh, as you can see, from like 5 years ago, we increased this around 9.2. Okay, we increased the amount of e-waste generated, and it's estimated that in 10 years it will be like 75 megatons. Okay, the e-waste generated. What's the problem? Well, the problem it's that all of this amount of e-waste generated, we only right now we recycle less than 20% of the total amount of e-waste. So there is like around 80% that we don't know where it goes, and we don't know if it's treated in a good way or we are polluting the environment. Here, okay, just also to point, we like globally, there are 7.3 kilograms of e-waste generated per person in the world. But what happens? That in some countries they produce less, and in other countries that they are more developed, they produce more quantity. Here in Europe, more or less, we produce 16 kilograms of e-waste every year. So every of you with your fridge, when you throw your TV, you throw your smartphone, you are also collaborating to increase this e-waste generation. So how much does it, well, the equivalent, it will be like to, as you see, 5,400 tools per. And finally, just to put in the context, when we are not recycling all this 80% of waste, we are throwing to the environment this amount, okay, of pollutants that first of, like, like these TPCs, for example, they affect to the global warming, okay, but also, for example, the mercury that we have in some of the electronic devices, they is very toxic, and well, sometimes they end in the oceans, they go to the fish, and then from the fish they also can go into our diet. It's estimated, okay, yes, that right now that almost 20% of the e-waste generated, it apports like 10 billion of dollars. But as you see, if we are able to recycle and to reduce all this amount of e-waste, it, well, we will also be contribution. It's like it has like an economic importance. Okay. So David now he's going to continue with the circular economy. Okay, so he will put also I put like the risk of the environmental and social impacts of e-waste, and he will say what is the solution. So David, if you want to continue, thanks.
Yes, thank you, Miguel. Well, I'm going to talk to you, as said Miguel, a little bit about circular economy. First of all, I want to show you some data. If you ask, is our way of life sustainable? Well, there are a lot of studies that say that we need to improve our way of life. For example, here um, you can see that there is something called Earth Overshoot Day. This is the day when we start to be in debt to the Earth. So this day is earlier and earlier every year. In 2020, fell on August 22. This is not very good news. We need to make some changes because if this day is next year in July, the next in June, we can have bigger problems than we are having now. There is also some people that study the number of Earths that we are using. And as average, we are using 1.5 Earth. We are here. The thing is, we are going to change this tendency that is increasing. If we don't change our way of life, our economy, this would be what happens at 2030. But we can change, okay? We can improve our production systems and be more sustainable in the future. Of course, there is a big problem, and the population is increasing a lot, and this is opposite to a sustainable life. I mean, when the world population increases, it is more difficult to be sustainable. Some more data for you to think about. And this is something that I like a lot because it's something that you see every day: mobile phones and cars. So mobile phones, we have a lot. We have 4.78 billion mobile phones today. The problem is not just the number of phones, but we use them in average 2.5 years. So every 2.5 years, we need to buy one new mobile phone. And the problem is that this is a lot. You can see here, if I have this web, and that I think you are going to like this web, because you can see the production of mobile phones in real time. So this is the problem when we say that we produced too much. This is the number of phones sold today, and this is the number of phones building in real time. Okay, so this obviously needs to change, or at least the production needs to change. We need to use our waste. We cannot produce this from raw materials from the earth in a sustainable way. If we see the cars, we have 1 billion cars in the earth. And again, if we go to the live counter or real time, this web starts counting when I have clicked the web. So this is the cars that are produced in real time. So since, I don't know, 10, 20 seconds ago that I clicked the web, 55, 60 cars are produced. So you can see here the problem with production. We are producing a lot. The world population is increasing. So we need to find some solutions. And these solutions are circular economy. You can see here a video that is very good about circular economy.
Living systems have been around for a few billion years and will be around for many more. In the living world, there's no landfill. Instead, materials flow. One species' waste is another's food. Energy is provided by the sun. Things grow, then die, and nutrients return to the soil safely. And it works. Yet as humans, we've adopted a linear approach. We take, we make, and we dispose. A new phone comes out, so we ditch the old one. Our washing machine packs up, so we buy another. Each time we do this, we're eating into a finite supply of resources and often producing toxic waste. It simply can't work long term. So what can? If we accept that the living world's cyclical model works, can we change our way of thinking so that we too operate a circular economy? Let's start with the biological cycle. How can our waste build capital rather than reduce it? By rethinking and redesigning products and components, and the packaging they come in, we can create safe and compostable materials that help grow more stuff. As they say in the movies, no resources have been lost in the making of this material. So what about the washing machines, mobile phones, fridges? We know they don't biodegrade. Here, we're talking about another sort of rethink, a way to cycle valuable metals, polymers, and alloys, so they maintain their quality and continue to be useful beyond the shelf life of individual products. What if the goods of today became the resources of tomorrow? It makes commercial sense. Instead of the throw away and replace culture we've become used to, we'd adopt a return and renew one, where products and components are designed to be disassembled and regenerated. One solution may be to rethink the way we view ownership. What if we never actually owned our technologies? We simply licensed them from the manufacturers. Now, let's put these two cycles together. Imagine if we could design products to come back to their makers, their technical materials being reused and their biological parts increasing agricultural value. And imagine that these products are made and transported using renewable energy. Here we have a model that builds prosperity long term. And the good news is, there are already companies out there who are beginning to adopt this way of working. But the circular economy isn't about one manufacturer changing one product. It's about all the interconnecting companies that form our infrastructure and economy coming together. It's about energy. It's about rethinking the operating system itself. We have a fantastic opportunity to open new perspectives and new horizons. Instead of remaining trapped in the frustrations of the present, with creativity and innovation, we really can rethink and redesign our future.
Okay, well, I think this is a very good introduction to circular economy. And as you can see, circular economy is based on a circular way of production. So everything starts with waste, okay? So we have a lot of waste. Europe still generates about 5 tons of waste per person per year. This is a lot. So we need to recycle this waste, to process this waste, and to obtain these raw materials from this waste. In that way, we reduce mining and exploration. And this is basically what we had a few years ago about the 3 R's: reduce, reuse, and recycle, but in a more efficient way. Okay. One thing that I want to point out is that in this circle, up to 80% of products' environmental impacts are determined at the design phase. Okay, so this phase is key, and maybe if you work in the future in engineering, in science, you are going to work here trying to improve the design phase because it's key in this process. Okay, so well, I'm going to finish this presentation about circular economy, giving you some data about key product value chains. Okay, so for example, in electronics, are we recycling in the European Union? Well, less than 40% of electronics waste is recycled in the European Union. So we need to improve this. Also about batteries, almost 50% is recycled, but we need to increase this percentage. About packaging is something that we need to battle a lot. We are producing 173 kilograms per inhabitant of packaging waste. This is a lot. If you go shopping one day, you take a lot of packages to your house. This is something that needs to change. About plastics, I think everyone is now has a lot of concern about plastics. Maybe this has changed a lot, but we need to improve because plastics are expected to double in the coming 20 years. And plastic don't biodegrade, okay? They stay there in the environment without biodegrading for many, many years. So we need to take care about that. Textiles, it's something that maybe we don't think about textiles so much, but please, if you have old clothes, you need to take them to a clean waste for them to recycle, but because textiles are important and the 4th highest pressure category for the use of primary raw materials and water, okay? And finishing, construction and building is very important because this generates a lot of waste. So we need to take care of the building materials. And finally, something that I think it's obvious, but many people think that the environment is important, but also many people don't do enough. So you need to act, and you need to change your way of life and the production processes when you are future engineers to be able to have a sustainable way of life.